Hello and welcome to the new episode of the Network and Cisco Packet Tracer tutorials for beginner. CRH is here, and in today's tutorial we are continuing on our routing protocols, and in today's topic we discuss about the EIGRP or Enhanced Interior Gateway Routing Protocol, which is originally the Cisco proprietary routing protocol, but in 2013 actually its partial functionality of EIGRP was converted to the open standard. Generally EIGRP is an hybrid or advanced distance vector routing protocol. It's considered hybrid because it's borrowed the simplicity of the distance vector routing protocol as well as the futuristics of the link state routing protocols. So it's simple, you can easily deploy it on your network, but at the same time it's very powerful and it can cater for the bigger network. It is a classless, so we can use the no auto summary in our function. It's a very good enhancement, so we can use the wildcard and show you on a configuration part. So let's begin. In previous video we saw that when we have a RIP, which is a distance vector routing protocol, we have a big problem. A router 0 to router 1 using the Bandlink, which is a very low bandwidth link. In the other hand, between router 0, router 2, router 3 and router 4 we have a high speed link, but due to the feature of the RIP, which is hop count, is choose the bottom pass and using the lower link to reach to the destination. If I ping, if you remember, we ping from the PC0 to PC3, and let's do it again. Okay, open the command prompt. This time I try to ping 192.168.40.10 or 30.10, which is the right side of the network here, as you can see, and we can do the ping. Let's wait for propagation time between the switches and routers. Okay, here we go, we have a ping, and let's trace route 192.168.40.10 and see what is our distance. As we can see, here we go, let's go here, and we have a these are our hopes. As you can see here, we go to 192.168.10.250, which is a gateway of the network 10, and we jump to the 172.16.2 and finally reach to destination 16.2 is this guys, 172.16.2, which is router 1 and is choosing the bottom path. So now let's enable the EIGRP. In this video I enable the EIGRP side by side by RIP to show you the difference. I might create another simple video only for setting up for EIGRP. That's for people who don't want to follow the video from the tutorial from the beginning, but I strongly recommend that to understand the real networking concept of the distance vector and link state routing protocol. You continue watching this video. So let's begin with the router 0. Let's check, do some basic check. Enable the router, show IP route. Let's see what we have here. Okay, here we go. We learned the RIP for other neighbors network, which is our WAN link. Most important part is here. As you can see here, we learned about 30.0 and 40.0 via 60.2, so we're using the bottom pass to reach to the other side. Okay, and let's start the configuration of the EIGRP side by side by RIP. So we go to global config mode, and the command is very simple, router EIGRP, and I show you the question mark. We need to choose the autonomous system number. The autonomous system or AS numbers identify the instance of the EIGRP, and one router can have a multiple AS, but bear in mind the routing of each AS, it will remain on that AS. So the router don't share the routing between the different AS running on the same router. You need another technology called redistribution. We will discuss later after we've fully covered all the routing protocol. Okay, router EIGRP, let's say you choose one, press enter. As mentioned, the good things about the EIGRP is a classless, so we can use the no auto summary, which is strongly recommended. We have a control over everything. No auto summary, and it's time to advertise the network. Let's start with our local network, LAN 01 and 02, 192.168.10.0. The good things, now we can choose the wildcard mask. Wildcard mask is very useful. We can specific which network we want to use. So I'm choosing since the 192.168.10.0 is a /24, we can using 0.0.0.255 and press enter. So it is basic commands for adding the network. First of all, we running the router EIGRP autonomous number 1, then we have a no auto summary here. Finally, we have a network, and how to calculate this wildcard mask is very simple. You can have it like 255.255.255.255 minus the real subnet mask, which is /24 255.255.255.0, and is equal to the 0.0.0.255. This is how we calculate the wildcard mask to specific our network being advertised in a EIGRP network. Okay, very good. Let's add another LAN, 192.168.20.0.0.0.255. Here we go. We have our network. So now I'm going to add the Bandlink. Since in our Bandlink we're using 172.16.0.2.0.4, and it's like I want with one command can cover up them. So, and the command will be one network 172.16.0.0.0.255.255. Okay, here we go, and our EIGRP configuration is done on a router 0. Let's take a look at the command. I'm exit and show run here to checking the EIGRP section. Goes down. This is the EIGRP section, which we have a RIP side by side still here. This is our RIP still running in this section, so we don't have anything with the RIP at the moment. EIGRP network 192.168.10.0, so we automatically remove the wildcard mask in a packet tracer version. You no need to worry about that. And let's start with the router 1, which is our main router here. Go to the CLI, enable the router. Let's check the show IP route. Here we go. We still have our RIP. We're learning about network 10 and 20 via RIP. This R stand here is actually showing that clearly is a RIP. And yeah, here we go. And we learn it from the neighbor 172.16.0.1, which is a router 0. Let's start the EIGRP configuration. So global configuration, router EIGRP autonomous 1. So this autonomous understand from the multicast is a neighbor is the same. It can start form the adjacency, neighbor adjacency, and start to broadcast the network. Advertise the network. Router EIGRP 1, no auto summary, best practice. Network 192.168.30.0.0.0.255. Use up arrow key, easy, fast. Let's do this. 192.168.40.0, and finally 172.16.0.0.0.255.255, and voila. Okay, immediately when I press enter for 172.16.0.0, we have a EIGRP neighbor adjacency is a new neighbor is linked together. And here let me explain more about this. 172.16, we want to take care about this part only, so we using .0.0. So when it's 0 is take care, when it's 255.255 is actually ignore. So here we don't care really about this section of the network because it's matched to the 255.255. Okay, very right. Okay, so we have a one command to see our network EIGRP neighbors, because without the neighbor adjacency formation, EIGRP router will not exchange the routes. So it's a very important command for you to check that the EIGRP status, and it's show IP EIGRP neighbors. Press enter. Here we go. Let's take a close look. So we have a form of address here with our neighbors, which is this guy here, other side, router 0, and through the WAT interface they connected. And here we go, and hold up timer, house is up, and other information which is more advanced we may discuss in a futures video. Okay, so now let's go back to our router 0, and this time, oh, okay, here we go. That's very good actually. So the neighbor adjacencies come up on the serial 03.0, and this time let's take a look at the show IP route. Okay, here we go. So now this time, if we compare, we learn about the 192.168.30.0 and 40.0 via our neighbor, which is still router 02. There's not much difference yet. We have to enable the routing on upper links, and as you can see, it's very important. We learned about our EIGRP, which is D here. So I think that previously they assigned E for other kind of routing. So now is the EIGRP, so they use a D as a EIGRP, and administrative distance is 90. So you can see here as administrative distance, if I can pronounce it properly, it is 90. Okay, here we go, and let's enable the router 2 and router 3 for EIGRP. We go to router 2, command enable show IP route. At the moment we have all the RIP configuration only. We learn about our neighbors through the RIP. That's it. And global config conft router EIGRP 1, and we have no auto summary, and we can advertise 172.16.0.0. that's the only available network with a wildcard mask of the 0.0.255.255, and the neighbor adjacencies come up very fast for a router 2. Let's go router 3, do the same thing, CLI. Okay, enabled global config mode, router EIGRP 1, no auto, and finally network 172.16.0.0.0.255.255. Wildcard mask is very powerful. You can be very specific. Here in this router we have a 2 network adjacency, so we formed a neighbor within 0.14, and we also have a 0.9, which is, if you take a look at our topology, this network LAN.9, which is router 2, and 14, which is router 2. So let's take a look at its show IP EIGRP neighbors, and here we can see that we have 2 neighbors, 14 and 19, as the previous message shows us. So we have a form of neighbor adjacency with these 2 routers, or neighbor routers, and both of them on a fast Ethernet link. If you remember, our fast Ethernet link was much more faster than a WAN link, and it's time to see that what's change happened on a routing from the router 0 perspective. Okay, show IP EIGRP. So we have a show IP EIGRP neighbor indeed. So we have 2 neighbors here, both router 1 and router 2, 6 and 2. This is how we connected through the serial and fast Ethernet. And show IP route. This time everything's changed through the EIGRP, but the beauty is here. Actually, you can see here now the routing is changed. Previously was through the router, another router, which was the router 0 to router 1, but this time actually is changed to the router 2, is with 172.16.0.6. So which means that EIGRP is intelligent enough to choose other criteria like a bandwidth, delay, jitter, and other information to choose the better route to the destination. Instead of the simple hop count, which is not really efficient, the EIGRP is able to make a correct decision, and based on the quality of the link, choose the better path to the destination. I want to show you some side-by-side route and route, but before that, let's go back to our PC0. We have a trace route here through the router 2, and now we're expecting to do the same routing and see the other path. So now, as you can see here, the number of paths is increased, but actually this is a much more faster. In previous we have connection through the router 1, but here we have a connection through the router 2 and router 3 and router 1, and final reach to the destination. So this link is much more efficient. Anyway, if you're enterprise, you can play with the different routing protocol or with different setting on EIGRP to have a multiple path. The good thing about the EIGRP is can have a immediate backup path in it, and you can switch immediately. We will discover this on a future video. I want to show you the small changes on a router 2 actually. Let's take a look at IP route from the router perspective. So as we expected, destination to 192.168.10 and 20.0 is changed to the EIGRP. This section you can see the D, and we have administrative distance of 90, and it's through the 192.168.13, which is this guy here, router 3. You see as the next hop for this network here, the router 1 see the path from this path. So it's very nice. Let me show you something interesting. I go to the global config mode, and on a router EIGRP 1 and say no network 192.168.40.0. I remove the network 192.168.40.0 from my EIGRP process. So the final config looks like something like this. Take a look. So we advertise 192.168.30.0 only from the EIGRP, but we advertise both 30 and 40 from the RIP. So we know that for 30, since the administrative distance of the EIGRP is lower than the RIP administrative distance, the 30 will be advertised via EIGRP. But since we don't advertise 40, we're expecting to see 192.168.40 via RIP on the other side. Let's check this. We go back to the router 0, so and show IP route this time side by side and take a closer look. Here we go. This is a big difference. Previously we advertised 192.168.40.0 via EIGRP, so we take over the higher administrative distance of the RIP. But here, since we remove it as we expected, is go back to the RIP. I'm trying to say, if you advertise your network from the different routing protocol, in this case EIGRP and RIP, the routing protocol with lower administrative distance, in this case 90 compared to 120, take over, which will happen for the router that actually is happen for a network 30. Here you can see I have a 30, still I have a 30, and as you saw just right now, we advertise 192.168.30 is still with the RIP, but EIGRP took over. So now this is a difference. So if I go back to my PC0 and trace route back, I still go back to 14 because I choose the other route to reach to that point. So let's put back the 14 on a configuration, conf t, router EIGRP 1, and let's add the network 192.168.40.000.255. Here we go, and let's go back to the router 0, show IP route, and very fast, as you can see, is a very fast convergence routing protocol from the RIP. Here we go back to the EIGRP here, very fast. So, and we can make sure that our network is very good condition. So this is a very quick video on EIGRP basic. You saw that how the two routing protocol like EIGRP and RIP can work side by side. As you can see, the configuration of the EIGRP is very easy. It's just most important thing is be careful of the disable the routing protocol at this stage, and no auto summary, sorry, and advertise your networks over the entire network. The routers, they know how to work properly, and they choose the best path, not only based on the hop count but also based on the quality of the link and bandwidth speed of the links between the among the paths between the router. I hope this is informative for you. If you like this video and find it useful, please like, subscribe to our channel, and as usual, please share our video among your colleagues or classmates. Will be appreciated if you receive your comments, and see you soon on our next coming video.